we want to find the inverse function, f inverse of x, if f of x equals 4 e to the 5x. All right, well, there's an algorithm for this. Let's bring that up. Steps for finding f inverse of x. Step 1, you replace f of x with y. Right, so this is a very nice method. It can be kind of challenging algebraically sometimes when you have to solve it, but let's see what we have here. So we replace f of x with y. So we have y equals 4 e to the 5x. Step 2, interchange x and y. So x equals 4 e to the 5y. Solve the equation for y. Okay, so this is usually the most challenging step, clearly. So let's do it. We divide both sides by 4. We get x over 4 equals e to the 5y. When you have a variable trapped in the exponent, the way to get it down is to natural log both sides, or log whatever log you would like. In this case, it makes sense to do the natural log since we're working with base e. What that does is it brings down this entire exponent down to the front. That's the rules of exponents there. So we have natural log x over 4 equals 5y, which we can then solve that for y to get, let's write it as 1/5 natural log x over 4. Finally, for step 4, replace y with f inverse of x. So what we have found is indeed the inverse of x. So we just write this as f inverse of x. So 1/5 natural log x over 4. There's the inverse. Let's take a look at the graph of this function and its inverse together on the same set of axes. Here's a graph quickly generated in Desmos. The red graph here is f of x, and the blue one is f inverse of x, and the green line, this is just y equals x. And what I'm showing here is that the function and its inverse are perfect mirror images across that line. It's a very nice thing, meaning if I folded across this line, this green line, y equals x, it would perfectly line up. The function and its inverse would perfectly line up on top of each other. That will always happen when you graph a function and its inverse on the same set of axes. You'll have this perfect mirror symmetry about the line y equals x. Let's try another one. For part B, we have find f inverse of x if f of x equals log base 10 of 4x. Okay, again with our steps, you follow these through every time you want to take the inverse. Some people even skip the swapping and just straight up essentially solve for x, but I like to still swap the variables and everything. Y equals log base 10 of 4x. Swap the variables, we can solve for y. X equals log base 10 of 4y. Now, when you want to get rid, when you have a variable trapped in a logarithm, there's a few ways to get it out. One way is to take both sides base whatever the logarithm base is. So I'm going to take both sides base 10. 10 to the log base 10 essentially undo each other. I could say cancel each other out, but that's not entirely accurate. They're inverse functions of each other, so they undo each other is a better way of thinking of it. What that leaves us with is 10 to the x equals 4y, which we can then solve. Y equals 10 to the x over 4. Finally, we write that in the proper notation. F inverse of x is 10 to the x over 4. Let's again look at both of these functions in Desmos. Again, we see this symmetry. Now f of x is the red one down here, the log, and f inverse of x is up here, the blue one, f inverse of x, and we have y equals x, our perfect diagonal line. But again, you have this nice mirror reflection across the diagonal, y equals x. You'll always see that behavior with a function and its inverse.